Hello everyone, I am Ankur Padhya and welcome to this amazing series called Low Level Design. In previous video, we already covered about the introduction, and in today's video, we are covering the 5 steps of low level design and NVT technique. So let's get started. As we already discussed about the 5 simple steps of implementing the low level design, first is requirement gathering, second one is laying down the use cases, third one is UML class diagram, fourth one is object oriented design to model a problem, and fifth is implementing a code using design patterns and solid principles. So from converting a class diagram to actual code is the main part of the low level design. So why we required this first two things, requirement gathering and laying down the use cases. So it will help us to create a UML class diagram. So let's understand it with the example. First thing that we get a requirement of creating a online course application where user can purchase the courses like we purchase the items from the Amazon. So this is our requirement. So let's laying down the use cases regarding this problem. So first we are going to the every step by step. First user open the app and then he selects codes and add them into the cart. After adding into the cart, user makes a payment and he get a callback message or feedback that is purchase is done or not. Okay. So after that, how can we create a UML class diagram using the NVT technique? So first is what is NVT technique? NVT technique is nothing but a noun verb technique. It's a simple rule to create the class diagrams and using the methods. So let's understand it with our use cases. First, finding all the nouns in our use cases. So at the previous slide, we laying down all the use cases. For the simplicity of the video, I make the use cases very small. So based upon your requirement, it can be critical and more sophisticated. But for the simplicity, I'm using this. So first understand that we have to find out all the nouns from the use cases. Like user selects the codes and add them into the cart. So user is a noun. So we create a class called user. And what can the properties user can have? So user can have ID and name. You can add another properties, but for the simplicity, I'm using this. Then we have a noun called codes. So codes can have the ID, name, and price. After that, we have a cart. So cart have the ID and list of courses that get be selected by the user. After that, makes a payment. So payment is a noun. So what payment can have ID, type, and status. After that, gets a feedback message. So feedback is our next class, which can have the status and message. So this is all about the noun. So as you can see, let's make very easy to create a class diagram for the application. After that, we are learn about the what verb can do. So after selecting the noun, we are selecting all the verbs. So which can help us to create the functions for the class diagrams. So first we have a user selects the codes and add them into the card. So in that select is a noun is a verb and add is a verb. So for the user we can have a different function name called get username, but this is the card. So we have a add them into the cart. So we can have a function called add to cart into the card class. Okay, so after that makes the payment. So in the payment class, we have a method called make payment. So I write down a very small use cases. That's why it's giving a very small functions. But if you describe this very precisely, you can get the proper methods from this verb technique. And last is gets feedback message. So in the feedback message, we have a method called get feedback message, and we can also have a method called get status. So based upon your requirements, you can add the multiple methods. But this noun and verb technique help us to create the class diagram, and using the noun we can create the classes, and using the verb we can create the mandatory methods which is required for the class. Okay. After that, we you know implementing all these things till the UML class diagram, requirement gathering, laying down the use cases and UML class diagram. What we have to do is we have to implement the object oriented design to model problem. So what is object oriented design? So it's nothing but the implementing the OPS principle. What is the OPS principles? If you already know that, the encapsulation, inheritance, abstraction, and polymorphism. I'm not going to deep down into this because I'm just covering the very specific topic called is a relationship and has a relationship. So after implementing the class diagram, we understand that how we define the relationship between the classes. So we can have the two type of relationship. First is a relationship, and second one is has a relationship. So in is a relationship, we are simply use a inheritance, and in a has a relationship, we are using the composition or the aggregation. So what is the inheritance relationship or is a relationship? Simply, if I'm taking an example, so where we find the inheritance, there is a relationship like a dog is a animal and a car is a vehicle. So that show the inheritance, right? So in a generalized form, uh, of animal, dog is an item of the animal. Okay, as like that. So in generalized way, we call a vehicle, and we can also call a car vehicle. Okay, so how to implement it? So like we creating a class animal, and it can have a common methods like all animals have the sounds. So we add a method, common method like the make sound, and we extend the animal class and implement the different sound functionality of the animals. So hope you understand it. If you not, so we are covering this topic very deeply into the design patterns with the practical examples, so you understand it on those videos. Okay. After that, we have a has a relationship. In has a relationship, we have a two type of relationship, can be composition and aggregation. So first we understand what is has a relationship. After that, we learn what is composition and what is aggregation. So in composition, yeah, means in a has a relationship, that's uh, we are removable components. We are taking the removable components like a car has an engine. So from a car, a engine can be removed. Okay. A student has a book. So a book can be removed from a student. Okay. So that's all are the removable components. But if we take an example of is a relationship, so we can't uh, you know remove the animal from the dog. Okay. So this is a difference between the is a relationship and a has a relationship. So as you understand it, in this we are using the inheritance, and in this in a has a relationship we are using the injection. So like take an example, we creating a class called engine, and have a method called start engine started, and in that we are injecting the class, not extending. We are just injecting. As you can see this, we directly inject engine equals to, and we are using it directly. Okay, so that's how the injection will work in composition. So what is composition and what is aggregation? So like if there is no car, so there should not engine. Okay, so there is a proper dependency of engine into car into engine into car. So this is our composition. And what is aggregation? If a single entity can be survived, like there is a team, a cricket team or basketball team. So if there is no team, so a single player can be survived. Okay, so that's the aggregation. Sounds confusing? No worries. In the next video, we are understand it with the real examples. So thank you for today and have a great day.